Okay, today's video is a basic introduction into different material properties. What I'd like you to do is I'm going to explain the format, some questions. The main thing I want you to do is copy out the information and also draw pictures, write statements. This should help you with your recall. So this is a basic introduction. We're going to start first with hardness. So how we determine what hardness is the ability for that material to withstand scratching or indentation. So where you can test it for Rockwells is if you indent it, you measure the pressure used and also the size of the indentation. Hard material to use. Hard material is titanium. Toughness. Now people get toughness and hardness mixed up sometimes. Toughness is that material's ability to withstand a sudden impact without fracture. So if you put some metal into a vise and hit it with a hammer, if that material didn't bend or if it didn't snap, that means that material is tough. So steel tends to be a pretty good material for toughness. Compressive strength. So this is resistance to breaking under compression. So if you are pushing down on something, that's essentially what compressive strength is. So it's the pushing down force that's resistant to breaking under compression. And an excellent material for that is concrete, which is why it's used in things like bridges, because you've got all that weight on top and that's pushing it down and it can withstand that. Thermal expansion. This is a physical property. Basically, it's nothing to do with how a material reacts under a force, but it's how much the material expands when heated. So we all know that materials expand and they grow when it's hot and they contract when it's cold. Excellent material for that is Pyrex. That's the material used for cooking. So it might be used for things that use like test tubes and stuff in science. Essentially, it's a glass that's been mixed with another material, I think it's boron, and it makes it able to have a lower thermal expansion than normal glass and it stops it from smashing. Tensile strength, pretty much the opposite to compressive strength. Instead of it being pushed down, it's the ability to withstand it being pulled apart. So Kevlar is an excellent material for that. Next one, ductility. So that means we can get a chunk of material, usually a metal, and we can pull it and stretch it and we can pull it apart into long wires. So copper is obviously an excellent material for that, as it's pulled and drawn out into long wires. Elasticity. So if a load is applied to a material, it's the ability for that to go back to its original shape once that's been applied. So elastic deformation is where you can put a force onto a material and then it will spring back to its original shape. Plastic deformation, which is not on this PowerPoint, is when you've put a force onto that material and it's deformed past the point of it being able to spring back, so it's irreversible. So elastic's reversible, plastic is irreversible. Elastic bands are good material for that one. And the final one is corrosion resistance. So basically it doesn't rust. So most materials that contain iron rust, apart from one exception, which is stainless steel. That's mixed with iron and chromium, and what that does is it stops it from corroding, which is why it's used in a lot of kitchen utensils, etc. So I hope that gives you good general information around material properties. Remember, the ones that use forces behind them, hardness, toughness, compressive strength, tensile strength, etc., are mechanical properties. The others are physical, so corrosion resistance, thermal expansion are physical properties.